So can you guys see this? I'm in present mode?
Yes.
Okay.
Yes.
All right, so this is all good?
Yes.
Okay. So I'm gonna use the little pointer. If everyone's okay with that, can I use the pointer? I like
Yes.
the pointer. Okay, so fractions and decimals. I think I'm gonna, there we go. Okay, so fractions. Fractions are parts of a whole. In a fraction, the numerator, the top number, is divided by the denominator, the bottom number. So here's an example. In blue is the numerator, and at the bottom is the denominator. And this little line represents the division sign. So the 2/3 is the same as 2 divided by 3. And that's why fractions are pieces of a whole. 1/8 of a pie is one piece of that pie that's divided into 8 pieces. The bigger the denominator, the smaller the value of the fraction. This is because increasing the denominator increases the number of pieces you're dividing the whole into. And here's an example saying that 1/3 of a pie is much bigger than 1/6 of a pie because there's more pieces that you're dividing it into. In other words, the bigger the denominator, the closer the fraction is to 0. Does that make sense?
Yes.
Okay. So here's some practice questions if you guys want to go over this. I think I can annotate. So Anne has 24 pencils in a box. Anne has 24 pencils in a box. 18 pencils have number 2 marked on them, and the 6 are marked number 3. So 18 pencils have number 2, and then 6 are marked number 3. What fraction of the pencils are marked number 3? So in the problem, 6 of them are marked 3, and out of the entire total, there are 24. While this may seem like the answer, it's not simplified. And when you simplify, you need to break it down into the best it can be. So if we divide by 6 and divide by 6, we should get 1/4 as our answer. For the next question, Zoe spotted a total of 39 parrots in an aviary at the San Diego Zoo. She counted 18 macaws and 21 cockatoos. What fraction of the macaws did Zoe spot at the aviary? So, what fraction of macaws did Zoe spot at the aviary? Okay, aviary. So she spotted 18 macaws out of 39 parrots at the San Diego Zoo. And if we break it down, if we break it down, we should get 6/13 of the parrots and 1/4 of the pencils. There we go. Okay. Does everyone understand that? Did that make sense? Okay. In order to add and subtract two fractions, they must have the same denominator. Then you add or subtract the numbers in the numerator and leave the denominator the same. So we have here 4/5 minus 2/5 equals 2/5, because 4 minus 2 equals 2. And 3/6 plus 5/6 equals 8/6, because 3 plus 5 equals 8. And another way to think about this is if you do have a pie and it's split into fourths and you're missing 2/4 of it, you're missing 2/4 of it, so you have 2/4 and someone gives you another 2/4, you're adding this part back. So then you have 4/4 again, which is a total of 1. Why is my drawing not working? There we go. To multiply fractions, simply multiply the numerator and denominator, even if the denominators are different. So 2/3 times 1/5, another way to think of it is 2 times 1 over 3 times 5. So 2 times 1 is 2, and 3 times 5 is 15. Does that make sense? I just want to make sure I'm not going too fast, so. Alrighty, next one. To divide fractions. Flip the fraction you're dividing by and then multiply the two. So a sample would be 3/4 divided by 2/5. So 3/4 divided by 2/5. Can you guys see my annotating? I feel like it's a little small. Okay, so to flip the fraction you're dividing by. So 2/5 turns into 5/2. So a little thing that my teacher taught me was keep, change, flip. So we keep this first fraction the same, we change the sign of this one, and then flip the fraction here. So keep 3/4, we change the sign, and then flip. And then we multiply them. So 3 times 5 is 15, and 4 times 2 is 8, giving us 15/8. Okay, so here's some practice questions. Do you guys want to try these before I start solving them? And just give me a thumbs up if you're done. Do you guys want me to start solving them? Okay, so 6/7 times 3/8. 6 times 3 is 18. And 7 times 8 is 56. I think we do need to simplify this. So you guys just, do you want me to give you the answer key, or do you want me to solve with you? Let's try and simplify this first one. So I think they're both divisible by 2. So if we divide by 2, what will we get? 9 over Sorry, those are my siblings in the background. Are you guys able to write on this whiteboard? I think you are, right? So if you do want to, here, I'll take that. So yes, what you did here was correct. You kept the first, you changed the sign, and then you flipped the third, or the second fraction. So 1 times 6 is 6, and 3 times 5 is 15. And if we want to simplify it, divide by 3, get 2 over 5. So 2/5 here. And then if we want to simplify this one, I think this has already been simplified, but I think I just want to make sure. So 9/28.
So you first, thank you for like telling me this. It's been much easier, but I did this, then I didn't know how to do it. So now I know.
Okay, well, I'm glad I'm helping you, so that's good, right?
Yeah.
So let's see, the third question. A glass pitcher holds 6 1/3 cups of pineapple juice. Tracy pours the juice evenly into 3 bottles. Okay, how many cups of juice will each bottle contain? So let's first try and think about what they're asking us. She's got 6 1/3 cups of pineapple juice, and she's pouring it evenly into 3 bottles. Now, this may look difficult at first, but usually what I do is try and convert it into improper fractions.
Can I think I know how to do this.
Do you want to try?
Each person, what?
Do you want to try it?
Yeah, each person gets 1. Is this correct? Because it's like 2 plus 1/2. 1 and 1, 1-1, I don't know how to say it, plus another 3 of those equals 6 1/3, 6 1/3.
Well, let's see if you're right. So what I usually do to solve this is change them into improper fractions. So what would make it look easier is if 6 times 3 is 18 and 18 plus 1 is 19, because 19/3 is the same as 6 1/3. It's just all on the numerator. And then divide by, instead of just putting 3, you can put 3 over 1 just to make it simple. And then we can keep, change, flip. So we keep 19 over 3, change, and then flip 1/3. So that will give us 19 over 9 times 3, which is 27. And I think that's simplified all the way down. So 19/27, I think, is the answer. Do you guys you want me to do the fourth one?
Can I do the fourth one?
Sure.
Okay.
Here, if you don't have enough room, I think I can just write the answers at the top and then erase everything else.
32 divided by 1.
You can use the space that I'm erasing if you want to.
Okay. $32. That's 4. That doesn't make sense.
Do you want me to help you out?
Yeah.
Okay. So
It's
Abigail's
much
hair.
easier. So
Abigail's hair is 32 inches long. She wants to cut off 1/4 of it. Okay, so I can see why it may seem confusing. So if her hair is 32 inches long and she wants to cut off 1/4,
you have to first make it into. You have to first make the 32 inches into a fraction, right? So it would be much easier.
well, in a way, it's kind of saying that we're taking away a fourth. Well, that's exactly what it's saying. It's saying that we want to cut off 1/4 of it. So the first thing we have to do is figure out what is 1/4 of 32.
1/4 of. Does that equal to 32 minus 4?
32 divided by 4 would be 1/4 of her hair.
Okay.
So 32 divided by 4 is 8. So 1/4 of her hair is 8 inches. But that isn't the answer because they're asking how long will her hair be after she gets the haircut. So what we have to do is subtract her hair before the
32
haircut.
minus 8,
Mm-hmm.
right?
Yeah.
32 minus 8, right?
Mm-hmm. And what will that give us?
So that will equal to, let me see, 32. Just go. That would equal to 24.
Mm-hmm. That's right. 24 inches. So let's write the answer at the top. And then we can see if we got it all right. Okay, so the first one, 9/28, yep. 2/5, yep. Hang on. Ooh, I don't think we did this one right. Hang on. 2 1/9 cups of juice. But we did get this one right. So, is there a way I can go back? Oh no, I don't think I can go back.
I think I know why you got that wrong. I think you have to cut it into half again.
Yeah, so she had 6
fraction
1/3 and she was trying to divide it into 3 glasses. So this is what what would be an easier way is 6 divided by 3 and then 1/3 divided by 3. So we get 2 here and 1/3 divided by 3. Keep, change, flip.
But I got the 2 correct. 2, 1, and it's supposed to be a 1 here, but there's a 9. So how's it 2, 1, 9?
Okay, so I understand what I did wrong. So what she was asking was 6 1/3, right? Divided by 3. So I should have done a simpler way by breaking it down. And what I mean by that is doing this. So we're dividing the 6 and 1/3. So we can put it as 6 divided by 3 and 1/3 divided by 3. Now 6 divided by 3 is 2. So we've got half of our answer right here. And then 1/3 divided by 3, we're going to need to use keep, change, flip.
Flip.
So 1/3 times, and what we're seeing right now is 3/1. So it would be 1/3, which would be 1/9. So the answer is 2 plus 1/9, which is 2 and 1/9. Sorry, I guess I made a little mistake.
Okay.
Does that make more sense?
Yeah.
Okay. Alrighty. To add and subtract fractions with different denominators, you need to first find a common denominator. Then you can add them like you normally would. The common denominator is the least common multiple of both denominators. So the common denominator of 1/5, and 1/3 is 15. The common denominator of 1/6 and 1/4 is 12. Does that make sense?
Okay. Yeah.
Then multiply both the numerator and denominator of both fractions by the factor needed to get the common denominator. An example would be the common denominator of 1/7 and 1/3 is 21, because 21 is the least common multiple of 7 and 3. So what they're basically saying is 1/7 and 1/3. 1/3 is equal to 2/6, right? And then 2/14. I think what they're trying to say is we need to find a denominator that is a multiple of 3 and 7. So 7, 14, 21, 3, 6, 9, 12, 15, 18, 21. And 3 isn't a multiple of 14, and 7 isn't a multiple for any of these numbers. But 21 is, and you want to find the smallest one. So, let's see. To turn the denominator of 3 into 21, multiply it by 7, or to turn 7 into 21, multiply it by 3. So yeah, another way of thinking about this is to multiply them by each other. So times 3 times 3, 3, 1, and then times 7 times 7, 7, and 1. So if you need to add 1/7 and 1/3, then this is a great way so you can combine these fractions without having to worry about the denominator. So if you were to add 1/7 and 1/3, it will be 10 21st, yeah. So here's a sample. 6/7 plus 1/8. So find a common denominator. The least common multiple of 7 and 8 is 56. Because 7 times 8 is 56. Or if you want to double check, you can go 7, 14, 21, and all the way up to 56, and do the same with 8, just to make sure, if you want to. So then multiply the numerator and denominator by the same factor to get 56. So 6 over 7 times 8 over 8 to get what 6/7 is in 56. And then you do the same with 1/8. And then so you add the two, which gives us 55 over 56. Does that make sense?
Yes.
Okay. All right, let's do some practice. Do you guys want to try them first, and then I'll do them afterward?
So,
Do you want me to go over the first one? Oh, I see what you're doing. Okay. So, well, and as a kid, I actually did do this as well, which is a common mistake. The denominators are different, and you
oh
can't.
yeah, first you
Yeah.
have to even it, right?
They have to be the same denominator before you can add them.
Oh yeah, I forgot that.
But it's okay. Mistakes happen. It's part of being human.
So first you have to do this, then you have to do you have to minus it? So first you have to break the 10. No.
So
The
what
7.
what we would do first is find the
You have
least
to
common
add the
multiple.
7 plus. Wait, I have to tell you something. You have to add the 7 2. If you add the 7 2, you have to add the 1 2 2. You have. This stands for least common denominator.
This stands for least common multiple, LCM.
Oh yeah.
Yeah. So the least common multiple we need to find, or yeah, least common denominator. We would do, okay, so 1/7 and 9/10. We would multiply. I don't know if you guys use dots, but I use dots as multiplication symbols. But, so 10, 10, and then, wait, whoops, that's not right. Sorry, I meant 7, 7, and then 10 over 10. So 1 times 10 is 10, and then 7 times 10 is 70. So 9 times 7 is 63, and then 10 times 7 is 70. So 9/10 is 63/70. And then 1/7 is 10 over 70. And so if we're going to add these, we add them. 10 plus 63 is 73 70ths, which also equals 1 3 70ths. So that's our answer for the first problem. Our second problem is actually fairly easier because 2/12 and 1/6. 6 is a common multiple of 12. So in a way, all we have to do is multiply it by 2, and then we get 2/12. Because 1/6 is 2/12, and 2/12 is 2/12. So 2/12 plus 2/12 is 4/12. And a way to simplify that, divide by 4, divide by 4, that is 1/3. For the third question, 1/2 plus 7/5. We do times 2 over 2 times 5 over 5. 5 over 10. So 1/2 is 5/10 because 5 times 2 is 10. And 7/5 times 2 is 14/10. So if we add these two, 5/10 plus 14/10, we get 19/10, which is also 1 9/10. Is this slowly starting to click a bit? Okay, so I think we can do the fourth question as well. A recipe for banana pudding calls for 2/3 cups of sugar for the batter and 1/4 cups of sugar for the topping. How many cups of sugar in all does the recipe need? So it's asking us 2/3 plus 1/4. The least common denominator in this situation is 12 because 2/3, 1/4 times 3 over 3 times 4 over 4, we get 8/12, 3/12. So 8/12 plus 3/12 equals 11/12. And that's the answer for the last one.
Okay.
Do you want to see if we got them right? Let's see.
Okay.
So 63 70ths. Ooh. I probably miscalculated. Hang on.
And this is wrong too. There's a pattern. Wrong, correct, wrong, correct.
Why is that? It is asking, so let's see what we did wrong. 1/2 plus 7/5. Okay, so 1/2 is 5/10, and 7/5 is 14/10. Okay, wait, this one's right. Yeah, this one's right. Okay, so that one's right, that one's right, that one's right. It's just this one. So this one, it was asking 1/7 9/10. So 10/70ths, and then, yeah, because 9 times 7, that is 63 though. I feel like this answer is miscalculated. I think it's supposed to be.
But the answer is 1/3. It's
Yeah, I think
but you
this
did.
is. I think the answer is 73/70ths. Because 9 times 7 is 63, and 63 over 70 plus 10 over 70 would be 73/70ths. So I think this was just a minor technicality, but I mean, we learn, right?
Yeah.
Okay, so have we all got this?
Yes.
Alrighty. To compare fractions, find a common denominator and convert. Here's an example. Okay. So is 5/12 or 3/7 larger? So we need to find the common denominator. So 5/12 and 3/7.
3/7. I think. Yeah, 3/7.
So this is bigger. 3/7
Yeah.
is bigger than 5/12. Okay, so let's do some practice. Arrange the following fractions on the number line. Okay, so we've got 6. We've got 6, 10, 7, 8, and 9. Okay, so this may be a bit difficult because while they do all have a common denominator, there's more than one. So do you guys want to try this out first and see what you get, or do you want me to? And it's okay to get things wrong. It's how you learn, right?
Yeah. So what should we do? We have to say like which is first.
So on the number line, it goes from least to greatest. So I think that's what it's asking us, to go
6,
from least to greatest.
6, 7, 8, 9, 10. 6, 7, 8, 9, 10.
So I do think that we need to find a common denominator. So
So the numerators don't count them. Does the numerators count or don't count?
So the reason why we wouldn't do 5, 6, 3/7 is because of the numerators as well.
Oh yeah, you have to count the numerators. It's all in the numerators. 7. I think it's first from 1. It's 1/10, 3/7,
Okay, so
5/6, 5/8, and 7/9. I think the others like that.
do you think it's like that?
Yeah.
All right. Do you want me to check the key, or
Check the key.
here? Let's see if you got it right. So,
What?
oh, why does it say 4/7? It should say 3.
The why is there? Never mind.
Okay. So you did get the first 2 right.
Yes.
You got 1/10 and 3/7. However, these 3 might be different, and I'll explain why.
Oh.
But it's okay. I mean, you were close. So if we have 3 pies, and this first one,
I think the third one too correct. I did the third one correct too. Wait, never mind. I didn't.
So if I know this isn't even, but bear with me. So this is divided into 6 pieces, right? Hang on, maybe it'd be better if I. Okay. So there we go. There we go. That looks about even. Okay. And if this is going to be divided into 8ths and 9ths, ooh. Okay. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, that's not even, but so when it comes to pieces, and I think we can recall in a previous, I don't know how to go back. Why can't I go back?
I think you have to go.
There we go. Hang on. So, okay, the bigger the denominator, the smaller it is, and the closer you're getting to 0. So, if we go back, if we arrange, okay, so we have 5, 6, 1, 2, 3, 4, 5. Or maybe I should do blue because I like the color blue. There we go. And then 5 8ths, 1, 2, 3, 4, 5. And then 7 9ths, 1, 2, 3, 4, 5, 6, 7. Okay. So 5 6ths, you can tell that there's only one more piece for it to be whole. So it would be in the front. And the next one is 7 9ths, which is closer to being a whole because it's only got 2 left. And then 5 8ths. Does that make sense? Because 1 is technically a full pizza.
Oh yeah, this is close to being, oh, now I get it.
Yeah, this is the closest, this is second, and then this is third.
I know it, I know it.
But you were close.
That's why. Okay. I want to do this. Can I do this again, but in like different denominators?
I think we have another practice. Let's see. Okay, so dividing the numerator of a fraction by its denominator gives you we're getting into decimals this time. Okay, so we've moved on from fractions. I think that's the last of fractions. And now we're going into decimals. Okay, so. Okay, so dividing the numerator of a fraction by its denominator gives you a decimal. The fraction and its decimal are equal. So 1/5 is also 0.2. So 1 divided by 5 is 0.2. Like fractions, numbers in decimal places represent parts of a whole. So decimals do represent parts of a whole as well. Any number with only 0 in its decimal place is equivalent to the whole number. This also applies to zeros after decimals. Example. So even though there are zeros here, this dot shows that it's only 1. And even though there's 3 zeros here, it's also the same as this. Does that make sense? Okay. To add decimals, stack them like 2-digit numbers. Carry digits like you normally would. Here's an example. So normally, if you're adding something, you would do this, and it's the same format, it's just there's a decimal point. Now you need to make sure that you line up the decimal points. because if you don't, then it will be the wrong answer. So 1.23. Because if I have like 0.095 and 0.3, you need to make sure you line these decimals up because the decimal points need to be in the same area. Subtracting decimals works the same way. I think the most important thing you need to learn out of this is that the decimal points need to be lined up. To multiply decimals, okay. Multiply the numbers.
How do you multiply decimals?
So this one may be a little difficult.
Adding decimals is easy, but multiplying decimals, I think I'll try. So in this, we have to multiply, like, we first have to multiply, the decimal points have to be the same. They have to be aligned, right?
Mm-hmm.
Then you have to multiply them, like 0 minus multiply by something, 5 multiply by something, 4 multiply by something. You have to.
Yeah, you are close. What you would do to multiply decimal places is to make them whole numbers. And to do that, for example, 0.3 and 1.5, we need to get rid of this decimal place. And by doing that, we will move it here. Because, let's see if I can find more room for this. 0.3, 1.5. And if we move it here, it becomes 15, right?
Yeah.
And if we move it here, it becomes 3. Okay. So now that we have that, we can do 15 times 3, which gets us 45. But it's not done yet. What we need to do next is count the decimal places that we took away and add them back. So we have one decimal place that was moved here and one decimal place that was moved here. So we put it back here because truthfully, there's always a decimal place. So this is just where it is now. And we're adding back those decimal places before. So 1, 2, we're putting that there. So the answer is 0.45. Does that make sense?
Yeah.
Okay.
Which
good.
is also called 45.
0.45.
0 and 45.
Yeah, 0.45. That's right.
But my other teacher says you have to say 0. I mean, like, if it's like this, 5.5 and 45. Like that.
Okay. Dividing decimals is a little more tricky. So if we're dividing decimals, okay, so we've got 0.11 and 0.53. Oh, whoops, I'm putting that in the wrong area. 0.539. Okay, so the first thing we need to do is get rid of the decimal point. So we move it twice, 1, 2. Now we only need to move the decimal points until the divisor, which is this little guy right here, is a whole number. So we only need to move it twice, 1, 2. So now it looks like this. Ooh, whoops. So now it looks like that. And let's see. Okay, so, and what I would do, using this decimal point, I move it up here. So now it looks like this. Oop. And it does say use long division to divide the new decimals without the decimal points, but I do add it up here just in case. So I'm gonna see if the directions has anything else. Okay, so let's see. Place the decimal point in your answer the same place as it is in the dividend. Okay, so instead of doing that, I would keep it here, but make sure. Okay, so let's just hold on. Let me follow the directions for now. So as you can see, the long division here is being worked out, and we have 49 right here. So when I move on to the next part, we need to place the decimal point back. And what they mean by that is to make sure hang on. Oh, is that right? Hang on, I'm gonna do this myself real quick. So 11, 539. Okay, so 11 goes into 53, or 11 goes into 50 times. And then bring down the 3. So 53. And it goes into 4. So 44, which gives us 9. Then we bring this down. 9. Or whoops. 99, 0. So 49. I think the way it was positioned. Yeah, this is not correct, I don't think. Well, wait, this is correct. But what it should look like is 4.9. There we go. Because if the dot is right here and we just move it up, then it would be 4.9. So the answer is actually 4.9. And I think I'm just gonna stop sharing real quick just to make sure. Here. Yeah, because yeah, that is 4.9. So yeah, sorry for the technical difficulties. So alrighty. So we're almost done. There we go. Okay, so let's do some practice problems. Okay, so try to ignore this part. Do you guys want to try these practice problems?
Can I try 0.31 minus 0.2?
Sure. You want to try that one?
Yeah.
All right, go for it. Here, I can set it up for you if you want. And a little helpful tip if you add a 0 here, just so it's easier.
It's 0.1 Is it 0.20?
So we're subtracting decimals. So 0.31 minus 0.2. So 1 minus 0 is 1, and
Yeah.
3 minus 2 is 1. We put the decimal point, and
Oh,
then we
yeah,
put the
yeah,
0.
yeah.
So the
It's
answer
11.
would be 0.11.
Okay.
So I'm going to write that up here, 0.11. Okay. So let's do, which one do you want me to do next?
0.93 divided by 0.3.
Okay, so 0.93 divided by 0.3. And the first thing we need to do is move the denominators, or move the decimal place so that the divisor is a whole number. So we only need to do that once. So 3 divided by 9.3. And for simplicity, I'm just going to put it up here. So now it should look like 3, there we go, 93, and then the decimal point up here. So 3 goes into 9 3 times. And then 3 goes into 3 1 time. So the answer for this fourth one is 3.1.
Okay.
All right, I'm going to do the top two. Let's see. Okay, so 2.1 divided by 0.4. So if we move this once, get 4 divided by 21 and put that up there. So 4 goes into 2 0 times. So 0. And 4 goes into 21 5 times. And so the thing about decimals is that there are infinite zeros after it. It's just, it would really hurt your hand if you wrote like a ton of zeros at the end. But with decimals, you can constantly pull zeros. So 4 goes into 10 2 times. And then if we pull another 0, 4 goes into 25 times.
5.25 remainder 20 20 0. I mean,
let's try the addition one.
0. The remainder is 0.
Yeah, there's no remainder.
Oh.
Okay, let's do the addition one. So for simplicity, we're going to put the 0 here. So 0 plus 9 is 9. 8 plus 3 is 11. 3 plus 2 plus 1 is 6. And then 1 plus 0 is 1. So 1.619. There we go.
Okay.
So if I erase all this, and we can do the last one and see if we're right. Okay. Miley buys a box of chocolates that contain 18.61 ounces of dark chocolate and 37.23 ounces of milk chocolate. How many total ounces of chocolate are there? So they're asking us to add it. Very close, actually. So I think the one thing that you did was you put 3 instead of 4. 3 plus 1, 4, 8, 15. You were very close. It's just this 3 is a 4. But other than that, great job.
Oh, yeah. Okay. Thank you.
No problem. Okay. So let's see if we got all these right.
You should list all the answers. Oh, yeah. Okay. You did. Okay.
Okay, here we go. Ready? We got the first one right.
Second one right. Third one right. Fourth one right. Fifth one right. Right. All of them are right.
Uh-oh. Something's happening with my computer. Hang on. Oop, there we go.
You have to click on the draw button
Yeah.
or mouse button.
All right. So I just need to quickly plug this in real quick because this is what I'm using to write. So, all right, there we go. I'll fix. And, ooh, what happened? All right. Clear drawings. And here's the homework. I'm not sure how I'm supposed to, I think we're supposed to post it in Google Classroom afterward. And here's the problem.
Oh, never mind.
And I think here's the key. So I think that's it.
I'll save this.
Is there maybe a way you can take a screenshot of this? So
yeah, just press save. There's a save button. You could save it.
Oh yeah. Okay. Alrighty. So I think that is it. And hopefully, like this is I think the second time I've tutored. So sorry if I'm a bit a little rusty, but. Hopefully I helped you all out, and if there's any other questions, I'll be right here. So is there anything else I need to clarify?
No.
Okay, all right, good. Thank you so much for being here though. I really appreciate it. I think, should we end it here? I mean, if you guys don't have any other questions, then. Okay. Thank you guys. Bye.